Assalamualaikum warahmatullahi wabarakatuh. My name is Joyda Minta Abu Bakar from University Utara Malaysia. Today I would like to present my paper entitled Color Image Enhancement of Acute Leukemia Cell in Blood Microscopic Image for Leukemia Detection Sample. This research is a collaboration between University Utara Malaysia and UiTM Penang. So there are 3 members from UM, led by Dr. Noh Hazlina Harun, me myself, Dr. Joyda Abu Bakar, and Dr. Hazaruddin Harun, and 2 from UiTM Penang, which is Dr. Muhammad Huzairi Osman and his student Zulkifli Abdul Wahab. So in this paper, in this presentation, I will discuss on 6 parts, which is introduction, research objective, previous work, methodology, result, and conclusion. So for the introduction, leukemia disease is a disease that affects blood-forming cell in the body. So it begins in the bone marrow. So it can be divided to 2, acute and chronic leukemia. So in this study, we are focusing on acute leukemia because it progresses fast and uncontrolled, and it attacks more on children below 5 years old. So there are 2 types of acute leukemia that we are going to discuss on this paper, which is ALL and AML. So all the sample has been collected from HUSM, Kubang Kerian, Kelantan, and we captured from blood sample. So example of image captured using Infinity 2 camera. We are using Infinity 2 camera attached on the top of LICA DLMA microscope. So figure 2.A shows the normal blood image, and you can see the white blood cell, okay, in the figure 2.A. In figure 2B and figure 2C, they are showing some abnormal white blood cell. So other than that, we also can see the cytoplasma and nucleus in the image. So for the present situation, we can see that the Malaysian population is the 6th most common cancer, 7 most common in male and 8 most common in female. This is cited by the National Cancer Registry Malaysia 2016. And based on the report by WHO 2014, we can see that the Malaysia itself is in ranking number 12 compared to the nearest country to Malaysia, such as Thailand and Indonesia is below than us, 4.2 and 4.12 compared to us, 4.22. So what triggered this study actually is because based on the problem, because many people die and the people itself died is between children below 5 years old. So in hospital, we always use manual microscopic investigation under the microscope, which is have error between 30% and 40%. They have expensive technology machine such as automated hematology analyzer, but it's quite expensive and is unbearable for medical laboratories, especially for developing countries like Malaysia. So for the solution, we try to figure out an automated diagnosis system based on a new enhancements method, which is a combination of particle swarm optimization algorithm, PSO, and contrast stretching. As we name it as a hybrid PSO-Contrast stretching. So the main objective of this project is to enhance the color image. Okay. compared to using a grayscale, RGB color. Now we move to the HSI color image saturation. So this is why we need to enhance the color image, because we want to for detection on the image processing method. So subtopic that we are going to cover in this study is, first we are going to develop an image segmentation algorithm based on PSO algorithm. Then to enhance the image using contrast stretching method and integrate the enhanced result with result of segmentation. And the last one, we are going to evaluate the performance of the proposed method with the different method image enhancement, such as ISCAIE and global enhancement. So for the scope of this project, we only study on 40 acute leukemia image provided by the HUSM Kubang Kriat, which is 30 of it is a type of AML and 10 of it is a type of ALL. So let's see the previous work related to this study. Okay. So normally paper related to this study can be divided to 3 stages. The first stage we call it as a leukocyte cell segmentation, the segmentation process. Then the second stage is feature extraction of leukocyte cell image. And the last stage is classification of leukemia cells. So the difference between my research with others, for example, we can see that previous research concentrate only one of the type acute leukemia, either AML or ALL. The second thing why we decide to have this research is because the researchers prefer analyze using single cell more easily as compare one image. And the third reason why we propose this topic is the researchers prefer to use image from bone marrow cause. Bone marrow cause the cell are produced there. Okay, we can see that study by Tera Umpon 2005, Lim 2005, 15 and Gaffo 2015. They focus on bone marrow cell only. Okay. Then the last reason why we propose this study is because most researchers prefer using gray level image as compared to RGB or HSI color space. Okay, such as the study in Mamoria and Raj 2016. They using gray image. Okay, in his study. So for the methodology, okay, in this study we are proposing 3 stages. Okay, the first stage, the original image from the RGB will be converted to the HSI color model conversion. Then the second stage, from the HSI color model, the saturation, which is S component, are taken to apply in the segmentation task. In the segmentation task, we use PSO algorithm. And the last stage, contrast stretching is applied, okay, to the PSO segmentation image. Okay, and after that, combination of stage 2 and 3 here, okay, we have what we call as a proposed method, which is we'll be going to compare with another 2 standard enhancement method, which is global and ISCAIE. So this is the figure related to the proposed method. And for the result, okay, this research start from color conversion. Okay, the original image was converted into HSI color space. The aim of for applying color conversion on original image is to enable the extraction of SSI, extraction of saturation component, what we call as a S component image from the color space. The S component has been chosen because it shows the best result for segmentation compared with hue and intensity component, where the nucleus part in acute leukemia cell image can be clearly seen. Okay, we can see it here. Even though that we change it to the background become a black color here. So next is segmentation using the PSO algorithm. For the proposed method, segmentation using PSO algorithm was selected as part of image enhancement. This algorithm will separate between nucleus part with unwanted part. Then, with suitable objective function applied in PSO, this algorithm will remove all the unwanted part except the nucleus. Hence, contrast stretching method was applied to the original image. In contrast stretching, the minimum and maximum pixel in red, green, and blue layer will be stretched until minimum point reach 0 and maximum point reach 255. After contrast stretching is completed, the result segmentation by PSO algorithm will be combined with contrast stretching to form a new enhancement method. So this is the enhanced image. Okay, we get after we apply this enhancement method, combination of these two methods. So for the result, we can see that our method here outperform the standard enhancement method, which is global and Clahe enhancement. So we can see that we get the lowest error, highest PSNR, and lowest AMBE. Same goes to the second AML image. We also get the lowest MSE, highest PSNR, lowest AMBE. Same goes to the ALL image. Okay, we get the lowest MSE, highest PSNR, dan lowest AMBE. So for because the image that we show just now is only 4 over than 30, 4 over than 10. So this is the average MSE, PSNR, and AMBE for all sample. 40 sample, 30 from AML, 10 from ALL. So we can see here that our technique, our method is outperform the standard method enhancement. Okay, so for the conclusion, it's proven that the hybrid PSO-Contrast method is important before proceeding to the leukemia screening in order to avoid misdiagnosis. So for the future work, we plan to apply on the clustering algorithm such as K-mean, fuzzy C-mean, moving K-means. This is to avoid pixel redundancy, dead center, and trap in local minima. I think that's all for today. For my presentation, if you have any question, please email to our researcher. Okay. So before I end my presentation, I want to show you the acknowledgement for this research. Okay, goes to the HUSM, School of Computing, CAS, UUM, and Faculty of Electrical Engineering. And also for the Malaysia government for providing this grant penjanaan with a SO code 13849. I think that's all from me. Thank you. Assalamualaikum.